Okay, silence. Thank you. Welcome to Stack Overflow, 100 million uniques per month on 9 web servers. Can everybody hear me? In the very back? Too loud? Can turn it down? Either way. Excellent. I'm David Haney. I'm an engineering manager at Stack Overflow, Stack Exchange. That's my Twitter handle. If you follow me, you can be number 500. I think that guy snagged it. It's all Twitter. I don't actually care. But interesting number. Thank you for coming. A little bit about me. Like I said, I'm the engineering manager of the core team at Stack Exchange. The core team is the question and answer team, so we take care of the websites and the related APIs, chat applications, etc. I'm a home brewing enthusiast. These are 2 beers that I brewed about 3 months ago. One of them was terrible and one of them was good, but if you've brewed beer before, you know that that's pretty standard. I'm an amateur runner, as in not really one at all these days, but I'm getting back into it. Big hockey fan, went and saw the Tampa Bay Lightning play back in January. It's a 3.5-hour drive from here, but totally worth it. I have awesome fashion sense. I'm actually wearing these pants today, which is sweet. But my wife took this photo to see on Facebook if people thought if I was styled enough to go outside, and even my dog in that photo is not sure, so it's pretty bad. And I'm learning new stuff every day. Knowing is half the battle. The other quarters are red lasers and blue lasers. All right, cool. I'm not going to take any questions during the conversation because I have like a full hour, but definitely feel free to talk to me. I'm very approachable. I don't actually know what I'm talking about, so it's great. I'll just make it up as I go. Or tweet me or any other way you can find me, but please don't stalk me. So a brief history of Stack Overflow. It was founded in 2008 by 2 fellows, Joel Spolsky and Jeff Atwood. In 2010, the Stack Exchange Network launched, which is the collection of sites known today. Things like Ask Ubuntu and Think Different or Ask Different, I guess it's called, the Apple site, etc., the gaming site. There's a DIY site. There's also 2 beer sites, and I participate in both. One you talk about beer, one you talk about brewing beer. It's pretty sweet. In 2011, Stack Overflow Careers was launched. It's basically the way that we make money. That's the #1 question I get asked is how do we make money? We run a job board that has a lot of machine learning and intelligence built into it, and we use that to sell jobs to developers. And the companies pay for the jobs, and the developers, see them and apply. That was weird. In 2014, Stack Overflow in Portuguese and Japanese launched. We have a Japanese designer named Jin Yang who bought a sword for the occasion and then tweeted about it. I don't know why, but why not? Also in 2014, we launched the native iOS and Android applications. And then in 2015, venture capitalists invested $40 million in us, which prompted the founder, Joel Spolsky, to tweet this. Specifically, I don't know if you can read that, but it says, "Okay, Stack HQ, time to upgrade our cappuccinos with shaved Varona chocolate and fresh cinnamon sticks, pound, send more VC." So we're using the money rather well. We have some mantras. A mantra is something that you repeat to yourself until you start to believe it, kind of like a truthful following, very Buddhist concept. It's actually a Zen concept. I don't know. It doesn't matter. Developers, we believe in smart and gets things done. So that's really about hiring people that are smart and get things done. How many people here are developers? Show of hands. Are you developers, or are you like the Steve Ballmer, like developers? How many people are not developers? That's right, I see you over there. This presentation is not for you. At the team level, we believe in moving fast and failing fast, so we're not afraid of failure. I don't want to really say we embrace failure, because that's a terrible thing to encourage, but we try things, we try new ideas, and as soon as they fail, we recognize that early and move on. That's what that means. And then as a company, we believe in what's called Pluralistic Management, which is the idea of pushing all the decisions. Flow. Google the things we need to figure out. We also, like I said earlier, try out new ideas and fail fast. So did anybody know that we used to sell the product by itself independently to businesses as like your own standalone Stack Overflow Q&A site that you could host internally? You did not know that because it went really poorly. We tried OpenID for logins. That also went poorly. We tried new exciting technology that none of us understood, particularly Postgres and Node.js. That also went poorly. So the key there is to recognize when you do something or try something new, it's not always better. But also, if it doesn't work, like, don't force it. Just stop and do something else. We're not perfect at that, honestly. In the case of Node.js, we tried it for a year before we realized we were bad at it. That was way too long, but you got to live and learn. We're not afraid of failure, and nor should you be. I mean, maybe in your personal life you should be, but like professionally, you should not be afraid of failure. You should avoid the no or that's impossible culture. Does anybody work there? Like you bring up ideas, they're like, that's impossible. That can't be done. There's no way. Try to get out of that. It's not as easy. It's easy for me to say that. It's very hard to do, but it's not a good thing. It doesn't lead to anything productive. Try every new idea that has merit. So the biggest mistake we ever made was in 2009, we had built a chat application on the internet that was like absolutely fully featured and allowed you to communicate as a team. And somebody said, hey, we should monetize that. And somebody else said, no, that's impossible and or stupid. And today Slack exists and makes billions of dollars. And we could have been them if we had thought to actually take that opportunity. So try everything that has any merit at all. You should aim to get the MVP live fast. That's so that you can either fail fast and stop wasting money or succeed and prove your point and start adding on features. You should recognize failure, pull the plug, and keep moving. It's really hard sometimes to recognize failure. There's a very interesting, one thing I'm very interested in is like meta-psychology and workplace psychology and like biases. There's a very interesting conflict of interest for managers and project managers, which is often they're on a project where the right thing to do is pull the plug, but that's wrong for them to do in terms of their personal success and career because it looks very badly upon them. And so there's a really interesting juxtaposition there that's hard to solve, but you need to be willing to pull the plug when something sucks. And in a good company and culture, people aren't going to blame you for that as the person who called it off. Failure is really, really important. There's a quote from Jeff Bezos at Amazon, which I'm going to now awkwardly read to you, even though you could read it yourself. He says, "I've made billions of dollars of failures at Amazon.com, literally. None of those things are fun, but they also don't matter. What really matters is that companies that don't continue to experiment, companies that don't embrace failure, they eventually get into a desperate position where the only thing they can do is make a Hail Mary bet at the very end of their corporate existence. I don't believe in bet the company bets." Does anybody, I mean, everybody here can probably think of a company that didn't try new things and then got to the end and tried something new and it sucked. I think of BlackBerry, typically. Windows Phone, you know, something that didn't go super well. Does anybody here have a Windows Phone? Are you going to like trade it in or? I don't even know what they're going to do with that. But the point is, if you don't innovate and you don't try new things and you get comfortable doing the thing you've always done, then you might get to a point where somebody does it better. You know, in the case of BlackBerry, Android and iPhone popped up, and they were like, well, all the enterprise people use BlackBerry, but then this whole culture of bring your own device to work came about, and now they're screwed. So don't do that. In any development team or company or open source project, developers are definitely the linchpin. The linchpin, by definition, is the one piece of the machine you can pull out to destroy the whole thing. So the message there is that developers are very important, and it's very important that you hire them correctly. If you think it's expensive to hire a professional to do the job, just wait till you hire an amateur, is the quote that I like. And then I have a sweet picture. Right? Like, this you know, I'm not made of money by far. It's a stretch for me to tell you that this tattoo cost me $6,000, but and 55 hours and like 40 sessions. But the point is, if I had gone to somebody who said they could draw the whole thing for $30, it would look like somebody drew the whole thing for $30. So it's important to get quality where it matters. The other thing I do in my personal life, which is way off topic, is I believe in putting money into anything that goes between me and the ground. So shoes, tires, mattresses, all these things tend to be very beneficial and important. If your tire blows on the highway, it's not awesome. So drop money on those. And strange PSA. You should always aim to hire smart developers who get things done. A developer must understand data structures and algorithms. I've worked with many that didn't. I myself did not for the first 2 years of my career, but I thought I did, and I had a huge ego, and it was really detrimental to my career initially. Developers should be able to identify the best data structure or algorithm for a given problem. That also sort of lends itself to not overcomplicating things. The way that I've seen this in the past is when people select the entire database into memory and then filter page sizes. Like, you know, they should be able to understand that paging is a good option, or some other non-memory structure is an excellent choice. Experience helps, but it's definitely not required. We do score to some degree people on experience when they apply for a job and when we hire them, but we don't require it. And some of our best hires are fresh out of school. The Mythical Man Month applies. Is anybody familiar with that concept? In short, it means that if a project is going over deadline or over budget, the natural response is to say, throw more people on the project. That actually delays it further because you have to spend time ramping those people up and whatnot. So it's better to hire people that can do the job than to hire people that cannot do the job and throw more people at the job, because that just costs you tons of money and goes forever. The important note here is that your hiring process, or process as I would say in Canada but have since become Americanized, should include code testing. I've worked at 3 jobs that did not code test me. All 3 of them were awful. Not totally awful, but you know, it just ends up where somebody's a very good salesperson. You know, has anybody here not worked with this person? Like, there's a really good salesperson, a developer that can really talk their stuff, seems to have all the answers, super brilliant. Then you hire them because they're super brilliant, then they can't write a line of code. Like, not one. Ashley's like, yeah, totally me, I do that. I don't believe you, but you know, that's an important thing. If you would you hire a doctor who didn't have a doctorate degree and hadn't proven to a board that they can do doctory things? Would you hire a lawyer who didn't have their license to argue to get you out of jail? Would you hire a developer for that $2 million product you just got funding for who you don't know can code? It's important. It's a valuable skill set, and it's essential to code test them. Have I stamped that yet? Code test your developers. Stamp it right in there. It's the only one I got. A few notes on hiring that I feel are important. This is a new slide. I think it's very important to include. Am I boring so far, by the way? Are we good? Entertaining? How many people are staring at their phones? 0. Amazing. Cool. Okay, so a few notes on hiring. When you're hiring, you should use neutral tone in writing for job descriptions. Earlier this year, we switched our job descriptions. They were written very masculine. They were very aggressive, looking for experts. The truth is, women actually don't identify themselves as experts, ever. 20% of the time they do, where men 80% of the time do. We're all experts in everything. And so we wrote our listings. We didn't really do much. We just took away a lot of the aggressive wording and wrote neutral listings and made an important statement about diversity, which I fully endorse. And bam, tons more people applying, not just women. People that don't have traditional degrees, people from other countries, people with visible and invisible minorities and diverse aspects. It's great. If you're not doing this, you're wasting a lot of opportunity to hire really brilliant people. And you see that in wording like, we're looking for the strongest, the best, the most experienced, an expert, a rock star ninja guru, Zen Buddhist mountain climber. All that crap doesn't matter. That's what I'm trying to say. Don't write it down. Fix your interviewing and hiring pipeline biases. Has anybody here ever actually noticed that you tend to hire people that are just like you? Because you do, and we did. It's just the reality of human nature, is that you're interested in associating with people who seem to have something in common with you that is not beneficial to employment. Because what happens is you all think the same way, and you engage in something called groupthink, and you make really stupid decisions. And I'm not preaching this like I'm above it. I have done this myself tons of times. But it's something we've realized and have started to work on. And that's another point on the people like me thing. Has anybody here been at a job where when you hired, you assessed cultural fit? Right? It's a hand in the back. It's a brave hand. Was it one of those things where you'd have a candidate that seemed pretty good, but they're just not a cultural fit, and so they're not hired? There you go. So you've been the experience of this. Cultural fit, in my practical experience, almost always means people like me. That's what it reduces to. So we explicitly ban rating cultural fit in our company. The question that naturally occurs is then how do you tell if somebody can work there? Well, if we assess personality and ease of conversation and ability to communicate, and if the person seems to have any red flags that we think would not allow us to work with them successfully, then we write that down. We say, they're not a self-starter, unable to really get motivated, they don't seem very excited. Those are valid reasons not to hire somebody, but if they happen to be living in Nigeria, like a person we interviewed a couple weeks was, that doesn't matter to me. We're going to hire them if they're good at the job, if they can pass the tests, It's important to not assess cultural fit. Should avoid credentialism, which is a really hard sell for a lot of big box companies. Banks, insurance companies are not going to avoid credentialism. Somebody at the top decided that you have to have a degree to program. Is anybody here a programmer who will admit they don't have a degree? Probably some of the best programmers in the room, honestly. And not to say that everybody else isn't good, but it's just some people have a calling for it. They don't want to get a 4-year degree. I don't blame them. Great developers come from everywhere. The moral of this preachy slide is don't miss out on a huge number of great developers. Fix your hiring biases. Definitely change the cultural tone to neutral of your job listings. Don't be super credentialist if you can avoid it. Try not to assess cultural fit. One of our very best developers right now, don't tell any of my other developers this, but one of our very best is a woman named Roberta, who lives in Brazil. Absolutely incredible developer. She's been out of school 4 months. She's been working with us for 4 months. She, the other day, disassembled in a class library and went down to the machine level instructions to identify a bug in .NET. I still haven't been able to do that. I've been at it for 8 years. So, but if we had bothered to say, she doesn't seem like us, doesn't talk like us, doesn't look like us, boom, would have missed out on her. Is that all clear? Preachy enough? Sweet. Our programming stack is primarily C#. ASP.NET MVC, Dapper ORM, StackExchange.Redis, which is a client that we wrote to connect to Redis as a service. I believe it's also endorsed by Microsoft currently and Azure. So if you're using Azure Redis, they'll tell you to download this. .NET OpenAuth, which is all about login and authentication. Mini Profiler, has anybody seen Mini Profiler in action? It's pretty useful. Nick Molnar, who's been here, wrote Glimpse, which is basically the same thing, arguably maybe even a little better. Either way, you should probably have one of those things installed to profile your application and keep track of what's not working well. We use Jill, which is the brainchild of a developer who was very fanatical about performance and serializers. And so he wrote this with assembly opcodes only in .NET. So he wrote a serializer for JSON, serializer, deserializer, and in assembly opcodes. It's impossible to maintain. It's like 50,000 lines, but it's very, very fast. Arguably the fastest out there, and he's got all kinds of benchmarks there. If you're wondering why these things are gold, or I guess they show up yellow, it's because they're links. So if you go and check out if you go and check out the slides later, you can click on all of these golden links here, and they'll take you to useful places and maybe a Rickroll or two. We also have a proprietary asynchronous Elasticsearch HTTP client. We believe in open sourcing almost everything we can. However, it's not open sourced because it's incomplete. It is a butchered and crippled version that we have written in only the features we use. So there's a bunch of features of Elasticsearch that we don't use and so aren't in the library, and so releasing it would not be beneficial. We're all about performance. Performance is the key to success in any application. A few people that I've seen talk this weekend have actually touched on this quite a bit, and I want to talk about it myself. People will leave your site or stop using your product or not buy things if it's slow or even perceived slow. When I worked at a company in town called Fanatics, we learned that every second that the page takes to load drops sales by something like 17%. At least it's diminishing returns, right? First 3 or 4 seconds is what I'm talking about. But it's very important if your application is used by any substantial number of users to be highly performance friendly and concerned with performance as a first-class thing in your company. Millions of users will amplify your mistakes. If you write a really inefficient SQL query, you'll get away with it. But once like 10,000 people start using it, it's going to fall down. Inefficient code destroys companies. I am at a blank for examples right now of a particular company that has gone poorly because of this, but back in the day I had a few in mind. Doesn't matter. It's obvious to think about, right? If people can't access your app and it's always down, it's perceived as unreliable, they'll go to your competitor, etc. And again, everything we do is focused on performance. Some stats about our site and network of sites. We have approximately 25 active production servers. They average 15% or less CPU usage. We have a 21 millisecond average question render time, and of note there, the questions actually are not cached and come straight out of the database every time you hit the page. This is probably pretty hard to read, but this is our architecture. There's 2 AHA proxy servers that point in round robin to 9 web servers, each of which have 48 gigs. Actually, nowadays they have 64 gigs. We upgraded it for funsies basically 2 months ago, but we still don't use all the RAM. We have 4 SQL servers that are organized in 2 clusters. One is for just Stack Overflow because it's huge and it's disproportionately larger than all of our other sites. We have a live and then a hot standby for Stack Overflow, and then we have the same for everything else, literally everything else. And those SQL servers have 384 gigs of RAM. We have 2 Redis servers, each of which has 96 gigs of RAM, and these are used for things like caching, a little bit of tag information and whatnot. We have 3 Elasticsearch servers that have 196 gigs of RAM, and they're load balanced. And we have 3 tag engine servers, which is like a custom set theory server that's used to, there's a query language we have for our sites where you can kind of combine tags and search terms, and it disambiguates and handles that for us. And they have 32 gigs of RAM. There's a performance page you can go to. I have no idea if I have internet, but we could try it. I don't have internet. But I also didn't try to connect to internet, so let's try that. OneOcean. How could this go wrong? I think I probably have to log in or something, right? Welcome to One Ocean. I do agree. That's weird. It's like a link and then next. Anyway. I am logged in. Great. So we have this performance page which lines out the details quite a bit more. So we transfer 48 terabytes of data a month. We have those 9 web servers. They handle 225 requests a second. We have the 4 SQL servers. They handle 440 million queries a day. And combined, they handle more like 790 million. The 2 Redis servers, that's the impressive bit. They handle 3.65 billion operations per day. 3 Tag Engine servers, 3,644 requests a minute. 3 Elasticsearch servers, or Elasticsearch services, pardon me. 34 million queries a day. 2 HA proxy servers. Those are just load balancers, not anything special that we wrote. And then WebSockets can handle 400,000 sustained connections. Again, our programming stack. At the end of the day, the home page loads in 52 milliseconds, and the question page loads at 33 milliseconds. And this is automatically updated, or will soon be automatically updated. I lost my presentation. Awesome. They are 48 gigs, I think. Yeah. I'm going to skip right ahead. It took over my presentation. We were here. Perfect. So our web tier performance, this is some actual stats that I just pulled. So that's the typical CPU usage on the web tier. This is where I usually go on my Node tirade because I hate Node, and I can tell you that .NET can be equally as performant if you write it correctly. I don't actually hate Node, I just don't like Node a lot. Has anybody read a blog post that's about Node versus .NET? If you did, I wrote that. So, it's actually an all right read. I originally wrote a really angry version of it, and then I kind of came back, more sober the next day and was like, maybe I should make this more neutral. But yeah, so that's the web tier. Not very much action on the servers themselves. That's the SQL tier. That's the impressive bit. So SQL servers, they max out the RAM because that's what SQL does. If anybody here is a DBA type, it takes up almost all the RAM that you give it to kind of page stuff in memory because it knows it's fast. But the CPU is 10%. And that's because we very aggressively tune all of our queries. And we have a lot of metrics and performance recorders installed to keep track of things when they go awry. On that note, the number one thing that screws up anybody's application is a database, even if you're using Node. If you write bad SQL code, it's going to be slow. Even if your code's asynchronous, if you write bad SQL code, it's going to be slow. Nick talked yesterday about a single point of failure being the database. That's exactly right. Does anybody here have an application that wouldn't crash and burn if the database went down? Exactly. So the database is very, very important. And I think, in my opinion, a lot of people undervalue and don't pay enough attention to how it operates and how to tune it and how to keep it healthy. What the heck? That's amazing. Why is that happening? I'll try something real quick. We're going to put it over here. I'm going to reload it. Okay, whatever. This wonderful library, by the way, where you can write your presentation in HTML is called Reveal.js. It's really, really good. Apparently, it's not so good with this presentation, but it's usually very good. Where was I? Performance, blah, 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 keys of success, some stats, some other stuff. Much better. Okay, so, whoa. Right, so tuning your databases. Efficient data structures use a lot less space. Everything in SQL is about page size. When you select data, it comes out in pages. So big int versus small int versus tiny int. If you're storing, everybody here's probably written a table, I would imagine, at some point. Has anybody been like, I'm going to use a big int because one day that primary key is going to get to 2.1 billion, and I'll totally optimize for that. I've done it. I did it a year ago. Totally. It's a thing that sort of makes sense. But the problem is it doubles the size of that key column. And so when you're paging, automatically you get less records per page. And the more pages you end up having to go over to do the query, the less efficient it is and the slower it is. So don't over-optimize it. very few people, including us, ever get to 2.1 billion anything. So just use an int. And if you think you're going to go down to maybe 65,000 or so, or actually not even 65,000. If you go down to, 65,000, right? 2 to the, I don't know. Small int's good also sometimes. And then tiny int can be really good. Effectively a little bit bigger than a bit, but a lot smaller than everything else. So if you had an enum that had 6 values or something, tiny int might be great because it can represent 8 values with the 8 bits. Can represent more than 8 values. I suck. I've been a manager for a while and I forget how to program. It's all good. 2 to the 8, whatever that is. So car versus varchar versus nvarchar. Does anybody know the difference between varchar and car? Anybody want to say it?
Char is a fixed length, varchar is a variable length up to the number of characters you specify, and varchar is Unicode for fixed variable number of characters.
Exactly. So if you have a char column, let's say you have you're building a dating site, right? And you have an about me section. And it's, say you write down 5,000 characters because they could write a lot and people like to talk about themselves on dating sites and such. If you use a char as a representative of that, then every single record takes up 5,000 bytes, even if they just say hello. If you use varchar, you got me on char for a while there. If you use varchar, then you can say that it's 5,000 length at maximum, but if they type in hello, it'll be approximately 5 bytes plus or minus some overhead. nvarchar is to represent Unicode, which is another eager optimization a lot of people will do, which is like one day we might be big in Japan, so we should support Unicode characters. Don't do that if you don't need to, because it takes up double the bytes per character, because Unicode is 2 bytes, where ASCII and such is 1 byte. Again, don't optimize prematurely. Big int identities is the one I see, or even GUID identities. Does anybody have like a GUID primary key in a database ever? That's like atrociously underperforming and inefficient. There's so many bytes. And it's also what's called fragmented because the GUIDs are typically not sequential and it just sucks. Indexes are really the key to good SQL performance. There's clustered and non-clustered. You can only have one clustered index because a clustered index is the physical sorting of the table. You should reserve your clustered index for the thing that is most queried, or the set of things that are most queried. You want your table to generally be in the order you query it in so that it doesn't have to do much work. Non-clustered indexes are sort of like pointers and trees that are built alongside of your table, very efficient, not quite as good as clustered, but still very good. Non-clustered indexes have a cost and benefit. So the cost is that there are these other sort of superfluous data structures that get created to store that data. And so when you do inserts or updates or deletes, all those data structures have to be updated at the same time. It takes care of that for you. But in short, it makes your operation slower. Inserts are slower, updates are slower, deletes are slower. But the benefit is that if you need to query your data in 2 or 3 ways, it becomes really, really fast. Because you've got your query index set up to do what's called covering your query, which we're going to get to in a minute. Oh, I didn't even have to explain that because it says it right there. The index size is related to the column size, so that's per the last slide. You really want to keep your page size down and use the appropriate data structures such that the index size also stays smaller, because all these problems just sort of magnify, right? If you start with inefficient structures and then crappy indexes, then as you start to actually index them because of your structures, the indexes get a lot bigger, and then the memory gets bloated, and then there's more paging, and it all just goes poorly. On the topic of queries and query plans, you should always set no count on unless you need to know the number of rows that came back exactly. And even then, in memory, you could count the number of rows. Because what happens when you don't set no count on is basically it returns your results, and it also returns a second result that's just the number of rows. And that's overhead on the wire that you don't need. Covered queries are really, really necessary. A covered query is a query which covers or includes all of the columns which you are selecting for your, yeah, that's right, sorry. Let me start that again. A covered query is a query for which an index exists that handles all of the columns that you're selecting. I could describe that differently. An index can cover a query when it indexes all the columns that you're selecting on. Query plans are almost always a direct result of indexes. So if your query plans are bad, then your indexes are bad. And you should look at the indexes and not try to recompile the query plans and tune them. You should analyze your query plans both proactively and reactively. There's actually two really unintuitive buttons in SQL Server Management Studio, which is like the anticipated query plan and then the actual query plan. The first one doesn't run the query, but the second one does, which is of note because you wouldn't want to necessarily do that if it's a problem. But it's really useful to go through and check those things and see what's slow and what it thinks it needs to do and then tune it accordingly. Has anybody tuned with a query plan before? Is it super hard or is it not bad? You know, a couple hours, you'll feel pretty comfortable. Just about as much time as it would take to spin up on Node.js. Sorry, I really hate Node. Seeks are good and scans are bad. So a seek is like a binary search where it knows where your data is because your indexes are good. And so it kind of jumps in log n time to where it is and returns it. And then a scan is like, I don't know where your data is because your indexes suck, so I'll just read every single record in the table until I find the thing you want. I hope it's obvious why that's bad. If it's not, then I'm an absolutely terrible presenter, which could also be true independently. Page sizes are related to the column size, like I talked about. So if you have efficient data structures, then your page size will be smaller, and that means you use less pages per query, and then things get faster. You should train your developers on SQL. Who here is a developer that works with SQL? Or some kind of SQL, I don't care, NoSQL, Mongo, whatever. Yeah, but how many of you have actually had your company buy you some training? Considerably less. And yet it's the single point of failure in your application and the most important thing that's also very easy to tune. So $300 now saves you a lot of dollars of on-call weekends and evenings and so on and so forth. Train your developers. Your app usually depends on a database like we talked about. A little knowledge often means huge gains. Funny story, there's this gent named Brent Ozar, who is basically the god king of SQL. Really, really, really talented. He has training courses online. I've been doing SQL for 10 years, exactly almost. I last year was like, I know everything there is to know about SQL. Never select star, so on and so forth. And then I took Stack Exchange bought me 8 hours of training, which they do for every new employee, from Brent Ozar on SQL. And 4 hours in, I was like, I'm a complete idiot, and I've ruined so many companies. Like none of the stuff that most people have learned, there are people that know SQL, don't get me wrong, but most of the stuff that you learn as a developer and you piece together from DBAs and their weird magic mystery advice isn't right, honestly. And I'm not trying to be condescending. I, up till last year, had it all wrong and thought I had it right. So 8 hours of training, which cost $199, like changed how I think about SQL, and now I'm much better, but still not perfect at writing SQL queries and tuning the database. There's lots of misinformation out there, and also, in my experience, lots of not so awesome DBAs. I'm sorry if that offends anybody here, but it's true. I hear things like never use select star, which makes no sense. Everything must be read uncommitted. Has anybody ever worked a job where they're like, everything has to be read uncommitted select? Dirty reads. That is a terrible warning sign that your whole database is set up very incorrectly, because it means that you can't hold a lock on anything because it breaks. And that's terrible. There are times when read uncommitted makes sense, and there are times when not using select star makes sense, right? Like, you wouldn't select star for an employee table when all you need is the first name and last name. You're just pulling down all this data over the wire and using a little bit of it. And you wouldn't want to lock the table up of transactions if you really just need to see the most recent ones, and it's okay if they're a couple seconds behind. But you shouldn't just do that verbatim for everything ever, which is what I learned from DBAs in my time, for example. Does that all make sense? Totally a little bit ahead, so I will take a couple questions if anybody has any as we go. SQL, Microsoft SQL, Oracle SQL is not always best. A lot of people, myself included, have thoroughly abused SQL in their applications. There are some examples here. Should use the right database for the job. Has anybody here ever used SQL full text search? Nobody? Oh, somebody in the back. Was it awesome? Yes or no? She's kind of like, not really. Yeah, SQL full text search sometimes works. It's not great. It ends up slowing down your SQL instance quite a bit. The thing that you could use there is Lucene or Elasticsearch. It's a way that it's built specifically just to search data, and it's very, very good at it. And what you can do is you can use your SQL as a source of record, but then like build a little service that feeds your data to the search service and then call the search service, and everything starts to work really well. And because you're offloading the work to your search service, your database stays low CPU. That's how ours stays so low, right? It's not that we're like super amazing. It's that the searching all gets done in the search application, not in SQL, for example. Has anybody here ever written an app that writes to table A, it writes to a table with app A and then app B reads that table? Maybe it's called like events or transactions or like things. And then like A will write like this one and then B will come pick that up and do something based on it. Has anybody ever done one of those as a way to like pass data around? That's a queue. And so you should use a queue. Right? And there's non-volatile queues, which can be like stored on disk, and there's something called guaranteed messaging, which can guarantee that the queue stays consistent, and there's things about ordering, but that's using SQL as a queue, and it's not the worst thing ever done, but it's not super performant. Has anybody here ever had like what's called the EAV table, or the entity attribute value table, which is like key value pairs in a table? Show of hands. Does anybody, do you know what I'm going to say right now? Does anybody know? Anybody want to shout it out? It's called NoSQL. Right? Mongo is, I don't know if anybody here's used Mongo. I've tried it, basically. That's another thing I hate. But it's like, the theme of if you take nothing else away, I hate things. That's what you need to know. No, so NoSQL is just storing keys and values. That's what it does, right? Like, it's pretty darn good at it, but there are some oddities in it. I saw a really funny joke on Twitter the other day that was like, congratulations to MongoDB on their 10 millionth download, or as their two servers reported it, 9,997,000 downloads and 10,003,000 downloads, because they have a thing called eventual consistency where they're not always in sync. So you won't want to store like bank information or money information in NoSQL, but you could definitely store a lot of lookup data and like dictionary type stuff, which is what was said over there. You should probably use them all at once. Right? SQL is your source of record, your one place of truth, and it's a great place to query things that make sense to query properly, like SQL, like customer records, etc. You know, Elasticsearch is great for searching text. Queues are great for push-pop type messaging, if you want to send things between applications in a way that they kind of are first in, first handled, or FIFO. NoSQL is great for free-form key value data, which is all kinds of data. Although the Mongo people will tell you that everything should be in Mongo because you know, they want to make money. You should never optimize prematurely. You know, I was talking about optimizing your tables. You should do that. I mean, that's a very impactful thing that will happen right away. But you know, work on getting the MVP out the door. Solve problems as they come up, not when you think they're going to be a problem in the near future, because it just honestly doesn't matter. Is that all clear so far? I don't seem to have anybody on their phones except that one guy over there. So far so good. Should cache everything that you can. So caching is the concept of storing calculated output for future method calls. It's like short-circuiting a method. So your typical cache method would say, like, let's say we call a method that's like calculate balance. The typical thing it would do is it would select 100 million rows and sum stuff up and return the balance, right? And that's slow per hit. So a caching system would be like, you call the same method, the first thing it does is says, okay, cache, do I have the result? If so, just return the result. And I'm done. And if not, do all that really hard work and then put it in the cache. And that way all the future calls will benefit from caching and be really, really fast. But the downside is your data will be a bit out of date, because caching is storing something for time, and so as it changes, it's out of date. Caching always trades CPU costs for memory costs, so, and that's expected. So you don't do as much work like I talked about. You store hard work into a cache and come and pull it back out. But it's going to take up more memory because you're putting it somewhere and holding on to it. Cache data is never real time, so things you should not cache include bank transactions, check deposits, withdrawals, right? You laugh, but Bank of America totally did this to me last year. It was insane. My account just didn't reflect anything I did that day. And I called, because, you know, what does that end up happening? Like, you're the developer, so you're like, no big deal, I'm optimizing. But then customer service is like, die. Because they get phone call after phone call, and they're like, where's my check? Where's my money? What happened? I was getting paid today. I don't see it. You know, think a little bit about what you're doing, and don't cache things that need to be real time, like paychecks. Unless you don't mind having your paycheck 2 days later just because. I do, but you may not. And lucky you. Performance profiling is really important. There's proactive and reactive performance profiling. Performance profiling is the art of basically figuring out where your code is slow and making it faster, which could be in the database, could be in the code itself, could be in something else. You should profile your code proactively in the dev environment or QA environment. So you should run a profiler, see what's slow, what's working. You should profile your code reactively in production, which means installing a profiling tool. I have a really good example of that, which I can now try to run on just that screen. It's going to be great. Is that Stack Overflow? OK, so this is Stack Overflow. You've all been there. I get fancy tools and you don't. One of them is the mini profiler prompt that I can look at that shows me what the site's doing. And it's actually saying, and the red here says that it was a little slower than it should have been. And so I look at that, and it says the SQL ran a little bit slower than it should have compared to usual. It's all sort of about averages and sample rates. The on-action executing, the Redis call was a bit slower than it should have been. And the get site switcher model top bar controller, whatever, Redis was slow there too. But SQL and Redis were only combined 56% or 57% exactly of the request. And there was a domain lookup that took 5 milliseconds and a response that took 47 milliseconds. And the DOM content loaded at 10 milliseconds. And a load event happened at 14 milliseconds. And the neat thing is you can kind of go in like, why was this SQL slow? And bam, I can actually go read about it and find out what was not going right and what was slow. In this case, it's warning me that this is a duplicate query. It happened more than once. In case I accidentally fat-fingered that, or I called it in a method and called it another method way down the chain. You can look through it and see what's happening. One of these will be bad somewhere probably. It's a lot of stuff for one page, right? But long story short, how many people here have the ability to get that insight into their application right now today? But how many people wish they could? Right? It's very valuable. So that's a great way to reactively, when your customer calls you and say stuff's exploding and really slow, the typical thing I used to do was like try it on my side and be like, it's fine on my end, it's fast. Right? Which is funny because it's true. But it would be greater if I could either automatically record their session and then go look it up later and see what went wrong in the background, which we do. Or go to the site, and if it is slow, look at it myself, and immediately, instead of just running through the code hoping to figure it out, be like, oh, that SQL query sucks, let me tune it. So it's important to pay attention to such tools and opportunities. And this is the tool that we built called Mini Profiler. Glimpse is equally as good. It's like Coke and Pepsi, you just pick one. They're both excellent. You should identify hot paths and fix inefficient code and queries. Basically, if you use a profiler, it's going to tell you what's slowest. Just make what's slowest not slow anymore, and then something new will become slowest. And just do that until diminishing returns. Use tools like WinDBG when an application crashes, which involves getting a dump file and then processing that dump file for information. I'm not going to talk a lot about that because it's like magical mystery pain. There's a slide coming up that makes fun of it. You should use tools like Mini Profiler, which I just showed you when your app is slow. And that's the example for when I don't have internets. You should always aim to write thread-safe and highly concurrent code. Thread safety is very important. It avoids race conditions and crashes. A thread-safe condition that would be bad, for example, is if the Bank of America team didn't write a very good method on customer balances, and then if I requested the balance and you requested the balance, then whoever last requested the balance, we both see that amount. That's your typical race condition. That would be very terrible in that case, but there are less harmful, more subtle versions of it. So the way you solve that is thread safety. It avoids basically mixing and exposing data across threads. Thread safety bugs, has anybody ever tried to diagnose one and fix it? It was super easy, right? It took you like 5 minutes. Yeah, it's really hard to track down because it only happens under a certain condition of timings of events that you can't really reproduce yourself. Local scope and state guarantees thread safety. This is why everybody says use local variables. They're automatically thread safe in almost every language except maybe Node.js. Yeah, digging it in. Immutable objects are thread safe by nature. Immutability means that it's read-only. So if you have an object that takes all its inputs from a constructor and then all the properties are getter only, that's an immutable object, and it's automatically thread safe because you can't change it. So no matter how many threads read it all at once, it still stays the same and it's fine. So that's a great way to get cheap thread safety where it makes sense. You should use locks when you do need to change things across threads. There's a couple of kinds of locks, which I won't get into super detail about, but locks are very important. Atomic operations are what locks provide, which means that only one thread can access that block of code at a given time, but they're very slow. So, locking blocks your other threads out till your thread's done. You should lock code and database sparingly, only when you absolutely need to, like withdrawing or adding money to a bank account would be a great example where you should absolutely lock because you don't want to mess that up. You don't want to accidentally overlook it or withdraw the wrong amount, etc. Lock when you must always read accurate data, so online banking is my go-to. Also lock when caching an expensive method call output. So if you're building a report, has anybody ever had a report they'd generate on a page that took like 30 seconds to do or 5 minutes? So you can lock that while you do the generation and then put it in the cache. And that way no other thread doubles up and triples up the work, because during that 30 seconds, everybody else who hits it also spawns up the work, and then your CPU goes to 100%. Locks are thread safe, but they're not concurrent by design, really. Cache, however, is highly concurrent. You should store data in cache whenever you can. Reading cache is cheap and non-blocking if it's worth its salt, which almost every caching system is, including Redis and everything else. Mongo, also very thread safe and concurrent. Cache everything and use local variable scope as much as you can. Garbage collection is really evil. Creating objects isn't free. So each created object must be tracked by the garbage collector and eventually reclaimed when you stop using it, but that's a non-deterministic algorithm and it's not very efficient. Most garbage collectors are generational. You can Google that if you're curious. The longer the object lives, the more expensive it is to destroy. That's about generations. Really large objects are also very expensive. And expensive and numerous collections cause GC stalls, which make your app pause, which is really bad. To investigate a GC stall, you would get a dump file when the stall is happening. Good luck with that. Use WinDBG to diagnose it. That's what WinDBG looks like. It's a whole other animal. It's not awesome. The best thing is just not to have to do this in the first place by properly handling your garbage collection. You should use object pools and short-lived objects. So object pools allow you to reuse an object. You can pull it off the pool, use it, put it back in the pool, and then usually when it gets put back in the pool, there's a reset method that cleans it all up and sets the data back to normal. If you don't do that, then you're basically creating a thread race, a race condition, because you're pulling the last person's object state and then assuming it's blank and it's not blank, and that's terrible. They solve GC issues because you reuse objects instead of creating and destroying them. I just said all this stuff basically. When you're done with it, put it back in the pool. If the pool is empty at pop, don't block, just create and return an object. It's going to happen once in a while. And pool no ops when the object count is greater than the limit. So if you did create those extra objects and you put them back in the pool, just don't do anything with them, just toss them out. You should manage the runtime. There's configuration and runtime settings that you can tweak in .NET, especially the process model in IIS. By default, IIS resets your application whenever 60% of your RAM gets used. I don't know if you knew that. So you really want to tweak it. There's no definitive way to tweak it. You just have to kind of play with it until it does what you want it to do. The runtime default is almost always terrible. So definitely do take time to tweak it. There's things in there like total threads and pools that you should adjust and account for. So the last bit is our development methodology. Managers support developers, like I talked about. We set the company goals and projects. We have an RFC system internally, which is an email group, which basically means that the developers can send their ideas via an RFC to a group of other developers who review it and ask questions and basically flesh out the idea. It's usually a 1 to 5 page doc at most. Nobody wants to read a manual of anything. Developers are trusted to make all technical decisions at Stack Exchange. Developers can recruit any person for any team as they need them. The only catch there is they should be needed. If anybody else can do it, then somebody else should do it. Managers ensure that projects move forward, and we remove obstacles. That could be waiting for a resource from design, or it could be like somebody having issues or conflicts between team members, etc. We absolutely hate meetings and email. So we don't do any project planning. We don't have any sprints. We don't do any estimates. We have no stand-ups and we have no scrums, and we think Agile's crap, generally. We have no status report emails. All scheduled meetings are discouraged, and you must have a good reason to have a meeting. We have one weekly status report meeting to update the team on the projects. On my team, it's at 3 p.m. Eastern on Mondays, lasts 90 minutes. But your typical developer attends 2 to 3 hours of meetings a week, and then codes for 37, which is a lot better than the opposite, right? Remote work culture. If one employee works remotely, the whole company must also work remotely. Scott Hanselman has some concerns with this on Twitter a lot because Microsoft doesn't have a remote work culture. So he's a remote employee who's kind of the odd man out. And they actually built a robot with a tablet head that they put him on, and they roll him around the office so he can be physically present in meetings. Because that's how averse they are to remote work culture. So if anybody goes remote, the whole company probably should too. All employees are issued a headset and webcam when we hire them, no matter where they work. All meetings are conducted in Google Hangouts and chat rooms. There are no meetings face-to-face anywhere. Remotes being remote workers, have access to both the Hangouts and the chat rooms, which prevents the isolation and feeling excluded. It also prevents the hallway conversations where you just don't know what's going on. And it prevents that conference call thing where you dial in and everybody ignores you and you can't talk over anybody, and then they all hang up and you're like, why did I even show up? I'm just going to eat Doritos. The workday is spent in chat rooms and Hangouts. You're expected to be there whenever you're at work. You can see everybody's conversations and project talk. We're public default, and so we don't have anybody having private conversations. So there's even cases where people in offices next to each other in New York City are having conversations on Google Hangouts and having conversations on chat because they're not allowed to go talk to each other, which sounds really awkward but works really well for remote work. We have a weekly beverage bash, which is a hangout where people can drink and chat. And we have a coffee roulette, which is where you're paired with a random employee for remote coffee, just to meet them and get to know who they are, because you can't walk around and say hi to people when you work remotely, which I do as well, by the way. So remote work culture, an example, I took this photo last week. There was or maybe a month ago, there was an inflatable giraffe hanging out behind Casey. I have no idea why, but this is an example of it. Casey and Joe's the third guy in the bottom there, they're literally sitting next to each other. Behind Joe is Casey, but they're still on the Hangout because that's fair to the remote employees and works well. So we're a distributed and diverse team. We have 35 developers, 6 sysadmins, and 6 designers. 75% of our engineering team is remote working. Very few are in the office. This is a picture of where they all are. So there's Roberto down there in Brazil. And there's Samo over there in, I don't know what that place is called, Slovenia maybe. And a ton of people in Europe and United States. And one guy in Alaska who's actually Jason Harvey, who we stole from Reddit. We are default public, so we love public artifacts and making the internet a better place. We encourage developers to blog about everything and speak at conferences and just be like good human beings to society in general. Developers interact with users on meta sites for feature requests through our product. Nearly all conversations held in chat rooms like I talked about. The exception to that is when I need to talk to an employee about something that's private or personal. It could be compensation or issues, etc. That'll be held in private. We believe in treating people well. Make your own hours and flexible work time. We are a results-oriented work environment. I track no hours. I don't care when people work. There's probably somebody working right now. In fact, I know there is. And I didn't tell them to, and that's what works on their schedule, and that's fine with me. And then they might not work Monday. Don't care. Work from anywhere you want. So I sometimes go down to, if anybody's in a local brews, I sometimes work from Intuition or Bold City or Veterans United or Ardwolf, just to change the scenery up for a day. Don't drink too much, because then you can't work. We have great vacation policies and limited sick days. We have excellent health and travel benefits. Almost all travel is first class with private drivers. On healthcare, the whole family gets 100% completely covered, $0 out-of-pocket healthcare. Employees are completely trusted to do their jobs, which makes them feel really happy. If you want happy developers, that's how you get happy developers. And we do this on a very low budget. I'm not allowed to talk specifically about money, but just know that we're not made of millions and millions and millions. It's not that hard for a company to afford these things for your employees. We believe in rapid iteration, like I talked about. So you never commit code that isn't ready for production. You keep it branched or behind a setting. We have automated build tools. One click will roll out to production any code. It'll basically talk to the load balancer, and it'll pull out a server, deploy the code to it, push it back in. We build to production probably 15 times a day, which is great because there's very few changes per release. And then if something breaks, we just roll it back and fix it and release it again really fast. And we have no QA people at all. We don't believe in QA, which is weird. Code reviews are only triggered voluntarily by authors of the code. Culture, last thing I'll say, is the most important. So, culture will eat strategy for lunch all day. Trust and transparency is a lot better than command and control and being told what to do and not buying in. Our practices create a great work culture of empowered and happy people. And people love what they do, and if they don't, they leave. And it's not that we ask them to leave, they just go elsewhere. We have very little turnover. We've lost 3 people in 6 years, I think, on engineering. And people leave to form and join startups typically. And that's great because it makes my life a lot easier, not to deal with a lot of disgruntled workers. So here's the plug, right? So we're hiring. We hire people who are smart and get things done. That link goes to a site where you can apply for a job with us. We'd love to have actually literally every one of you apply for a job. Be sweet. This is a statement I think is important. Diverse teams build better products. We strongly believe that diversity of experience contributes to a broader collective perspective that will consistently lead to a better company and better products. We're working hard to increase diversity of our teams wherever we can, and we actively encourage everyone to consider becoming a part of it. All clear? That's the whole thing. Thank you for coming.